Example 3, Part B. What is the domain of A? So I have my function a of x equals x squared plus 100 minus 40x plus 4x squared, all that over pi. So this function represents area. And in my function, the x value represents the side of this square. So we know that that side, that length, has to be positive. So my first restriction is x has to be positive. Also, in this problem, we're cutting a piece in a wire that's 20 meters long. So this piece 4x, it has to be less than 20 meters because you're cutting it from a piece that's 20 meters long. So our second restriction would be that 4x has to be less than 20. So if I divide both sides by 4 here, I'll get x is less than 5. So then the domain of my function, a, is going to be all the x's greater than 0 and less than 5, so between 0 and 5. In interval notation, that will be parenthesis 0, 5, close parentheses. Now, part C, we want to graph a equals a of x, and then find for what value of x is a smallest. So I'm going to enter into my graphing calculator my function. Be careful when you're entering this function that you enclose the numerator of that fraction in parentheses. Anytime you're entering kind of messy fractions, larger fractions, more than just one term in the numerator and denominator, it's always important to put enclose parentheses around that. So I enter my function. Now, we already know the x min, x max, because that's our domain. We know our domain, our x's are going to go from 0 to 5. Now, let's look at the table to find an approximate estimate here of appropriate y values in this viewing window. So we know our x's are going from 0 to 5. So if I look at all my y values in here, the highest I see is somewhere in the 30s. So I'm just going to put somewhere in the 30s. I'm going to go a little higher than I see here, 35, because this is certainly not all the x values in this region, just those whole number values. So I'm going to put approximately about 35. So in my viewing window, I've got 0 to 5, and that's from the domain we found in Part B. And then my y values, actually, yeah, this should be $35. And I'm going to change my scale to 5. I think it's easier to make always increase that scale when you increase the y value or the x value range. That's just indicating you'll have a tick mark every 5 units instead of every 1 unit. And I think that helps you visualize this better, make the graph more clear. Okay, so let's graph. And here we get our shape. Kind of looks like we can see a little dip in that graph, which is good because they're asking us for what value of x is a smallest. So we have a little dip, a little min, a local min there in that graph. So let's make a little sketch to have in our notes. Just approximate is all you need. And I suggest that you guys record the viewing window, so if you want to go back and check this, you know what viewing window we used on the graphing calculator. So we went from 0 to 5 with a scale of 1 on the x's. And then we went from 0 to 35 with a scale of 5 on the y-axis. Again, not the only viewing window that works, just one example. So I go back here and I want to calculate now. I want to calculate that min. So I'm going to hit second trace to calculate the min, option 3. So I'm going to just cursor a little bit left of where that dip occurs. So I'll hit enter for my left boundary. Now I'll cursor over to the right, or again, I can always enter an x value. And hit enter. And then I can just cursor over close to where I think that dip occurs. Again, the resolution on these calculators is not superb here, so just approximate it. Hit enter one more time. So I'm going to get my minimum occurring at an x value of approximately 2.8, and that actual minimum value is about 14. So we'll sketch this on our notes here. So we've got about 2.8 and about 14.0. Again, pay attention to rounding on the specific question in my math lab or the quiz or the test to see how they want us to round. I rounded to the nearest tenth. So for what value of x is a smallest? X is approximately 2.8.